Alright, hello. This video we're going to be going over 8.3 day 2. This section 8.3 is about being able to graph rational expressions. That's the goal, and we want to sketch these asymptotes, the horizontal and vertical. So remember, asymptotes are just like lines that the graph approaches but never reaches. So oftentimes I draw them with dashed lines. And so we're going to use those to create the graphs and our calculators. Right? So you're probably going to want access to a graphing calculator on this lesson. If you happen not to have one, remember there's one built into Rapid Identity that you can use. Okay, so our objective is to graph rational functions. So it's right there, graph rational function. And we kind of did the first couple parts in the first lesson. We factored, we learned how to do that, and then the vertical asymptotes and holes, that happens when the denominator is equal to 0, right? So you can either, you'll get like what's called a discontinuity or break, and it can either be an asymptote, vertical asymptote, or hole. So you look when the denominator is 0. And then today we're going to talk about how to find the horizontal asymptote. That'll just be a chart you're going to use. You can use the highest exponents in this chart. And then you're going to plot the asymptotes, so you'll graph them, right? You'll graph like a horizontal asymptote if it has one, and then maybe some vertical asymptotes. And then you're going to draw the graph, the rest of it, using the calculator. So like you'll draw it in around the asymptotes. And you get some crazy graphs, like you might even have 3 parts, sort of like what I'm attempting to draw here. So use your calculator to help graph it once you've got the asymptotes figured out. Okay, and so we've already did vertical. So today, one of the main things we're going to do is talk about how do you find that horizontal asymptote. Okay, so first thing is before we get that, let's review the vertical asymptote. So here's 3 examples and see if you can figure out, actually, so it says vertical asymptotes, but figure out if it has vertical asymptotes or holes in any of these graphs. So pause the video and see if you can remember how to do that. Okay, so these are what's called discontinuities, and so it'll break when the denominator is 0. So if you look at this example, if I set this little expression x plus 7 to 0, that would mean x can't be negative 7, right? And so the reason is we would have on the top, we'd have negative 12, and then we'd have negative 7 plus 7, 0. So we do negative 12 divided by 0, and that doesn't work. Okay, so basically x equals 7 is a discontinuity. And then graphically speaking, it can either make a vertical asymptote like this, or it can just make a hole in the graph at 7. So the trick is if it doesn't cancel, so if we look at this x plus 7 factor, and if there's nothing that cancels with it up top, then it is a vertical asymptote. So graphically, when we draw this one out at 7, there'll be a vertical asymptote going through 7. All right, let's try the second one. All right, so again, it's already factored in the denominator, which is kind of nice. So set each part to 0, and we'll get x equals 1 and x equals negative 3, and those are our breaks. Maybe I'll write them over here so I can label them. And this x minus 1 doesn't cancel up top, so it's, again, a vertical asymptote. And same thing with this plus 3. There's no matching factor up top, so it's another vertical asymptote. Right, so this graph happens to have 2 vertical asymptotes, one at 1 and one at 3. So when we graph it at 1 and at negative 3, there'll be vertical asymptotes. Okay, last one. If you set them to 0 again, you get x equals 2 and x equals minus 3. And the 2, because it matches and cancels like that, we're going to have a hole in our graph at 2. And for the plus 3, there is no matching factor up top, so that minus 3 is a vertical asymptote. Okay, so those are just, again, how you find the vertical asymptotes and holes. You look at the denominator and when it is 0. Okay, so horizontal asymptote, you can either have 1 or none. Vertical, you can have more than 1, but horizontally, you either have 1 or none, and it depends on the degree, the highest exponent in the numerator and the highest exponent in the denominator. So this little chart you're going to want to copy down, and you also maybe want to put here that m equals the highest exponent in the numerator and n is the highest exponent in denominator. Okay, And so you're going to take those two, and only one of three things can happen. M could be less than n, so in which case the horizontal asymptote is just the line y equals 0, which is actually the x-axis. If you wanted to make a note of that, y equals 0 is actually just the x-axis. Okay. You can, if they're equal, if the two exponents are equal, then the horizontal asymptote is the line y equals a over b. And this is, again, you probably want to make a quick note of this, that a is the leading coefficient of the numerator, and b is the leading coefficient of the denominator. Okay, and it'll make more sense as we do some examples if you forgot some of the vocab words there. And then if m is greater than n, then there isn't a horizontal asymptote. Okay, so I'm going to do an example here, and I think this will make it a lot more clear once you see a few of these examples. Okay, so m in this case is the 2. That's the highest exponent up top. N is the highest exponent in the denominator, also 2. So in our chart, we are in the middle case where they're equal. And so our horizontal asymptote is the line y equals a over b. So these are the leading coefficients. So here's the leading coefficient out top. Here's the one on the bottom. So it would be the line y equals 6 over 2 or y equals 3. Right, so when we graph this one, there'll be a horizontal asymptote up here at 3. We'll draw it in like that, and that's where our horizontal asymptote of the graph will be for this particular rational expression graph. Okay, so have your chart out, and then I'm going to have you try these 4 to find where's the horizontal asymptote. So this is really the main new thing for today. So pause the video here and see if you can use your chart to figure it out. Okay, so on this one, m is 1. That's our highest exponent up top. And n is 2, the highest exponent on the bottom. So we have m less than n. And I got to always look back. So on my chart, m less than n, then the horizontal asymptote is the line y equals 0. So here our horizontal asymptote is y equals 0. All right, next one we have m equals 3. Here's our highest exponent. And n is also equal to 3. So that's the middle case. So our horizontal asymptote is y equals a over b, where they're the leading coefficients. So we have a 2 here and a 1 in the bottom. So we do 2 over 1. So our horizontal asymptote is just the line y equals 2. All right, next one, m is 2, n is 1. This n is just a 1. So m is greater than n, so we have no horizontal asymptote. Okay, last one kind of slid off the page here, but m was actually 0. There's like a kind of like an x to the 0 here, and n is just 1. So we have m less than n again. So the horizontal asymptote in that case is y equals 0. Sorry, that says m less than n. Sorry, my pen is still kind of going wonky here. All right. So I think what's up next is we're going to put it all together. So we can find vertical asymptotes in wholes. Denominators equal 0. You can find the horizontal asymptote, and then we're just going to sketch those and draw the graph. Okay, so we're going to put it all together, and you're going to draw these asymptotes and then sketch the graph around it using the calculator. So sometimes you even get 3 parts like this. Sometimes you get 2 parts. Sometimes you get 1 part. It really depends. Your calculator can certainly help with that. All right, so let's try one of these. So here's our rational function, and there's those steps from the beginning of the video, so hopefully you jotted those down. Otherwise, look at the PDF notes out there. Okay, so kind of the first thing we want to do is like any wholes or vertical asymptotes, and that's going to happen when this is equal to 0, when the denominator is equal to 0. Okay, so we know that'll happen at x equals 2, but we've really got to figure out, is this going to be a vertical asymptote or a whole? And we do that by seeing if there's a matching x minus 2 up top. Okay, so that's why the first step is usually to factor. So I've actually got to factor this top and see if I get an x minus 2 and it cancels out. So we'll use x and x, and then multiply to -4 and add up to -3. So if it multiplies to a negative, there's one negative, one positive. And then to get -3, if we do -4 and +1, that'll add up to -3. Did not cancel then. So this x minus 2 has no cancel up top. So that means this is a vertical asymptote at 2. So I'm going to go to 2 right away and then just draw in my asymptote. Okay, so I draw it in the label. Now I'm going to do a horizontal asymptote. So I got to use that MN chart. So M and N are the highest exponents. So M is 2 and N is 1 right there. So according to the chart here, M is greater than N. So there's actually no horizontal asymptote in this case. So I have nothing to draw that for horizontal. Okay, so no holes, no horizontal asymptote, just a vertical asymptote at 2. Okay, so to figure out what this graph looks like, I'm just going to type it in my calculator and make sure to use parentheses. So surround the numerator in parentheses and the denominator in parentheses. Okay. All right, so into the y equals screen, clear everything out, do parentheses, x variable, and then square. Minus 3x minus 4, close parentheses, divide, close parentheses. I think it was x minus 2 in the bottom, so x minus 2. And then I'm just going to hit graph once I got it in there. Okay, and you can see kind of at 2, there's that asymptote, right? It's coming, gets closer, but it never hits x equal 2, and same thing going this way. So from here, I'm just going to roughly sketch that on my page. Okay, so now that I've got the graph, I'm just going to draw. I think it goes like this, and then goes zoom like that. Oops, I crossed the asymptote, that's no good. And then down like this, and then go across like that. So sorry, my graph's not very good, but draw it something like that to sketch what you see off the calculator. All right, let's try one more together, and then we'll call it good. So see if you can sketch the graph of this, starting with the asymptotes and holes, and sketch it in, and then go from there. All right, so each graph is a little bit different. So generally speaking, again, I want to factor first, and the numerator is just 3 times x times x. So kind of boring factoring there. But the bottom, remember, this is square minus square. So you can put x and x here, and then do -2 and +2, right? That multiplies to -4 and adds up to 0 x's in the middle. So that's what it factors to, right? Which means if you set that to 0, our 2 points of discontinuity are 2 and -2. All right, so those are the breaks on the x-axis here, x-axis. And then I want to figure out, are they asymptotes or holes? So if I look, these little x minus 2 and x plus 2 don't have a match up top. So these are both vertical asymptotes. So when I draw my graph, I'm going to go to 2 and -2 on the x-axis and draw in vertical asymptotes. Okay, so horizontal asymptote. Again, I'm going to use the chart, M and N. So m, the highest exponent in the top, is 2. N, the highest exponent in the denominator, also 2. So we have m equals to n. So the horizontal asymptote is y equals a over b, where those are the leading coefficients. So the leading coefficient on the top is 3, and the leading coefficient on the bottom is 1. So we're going to end up with a line y equals 3. So I'm going to draw that right here. Here's 3, and then just draw a asymptote going across there. Okay, now I got to figure out what the graph actually looks like, so that's where I'm going to use my calculator. And again, just make sure you use parentheses around the numerator and the denominator. Okay, so that's what it should look like entered in, again with parentheses around the numerator and denominator. Divide symbol between them, hit graph. And this one's going to have 3 parts, and you can kind of see the asymptote here at 3 for y, and then you can see the vertical ones at 2 and -2. You can kind of see it visually. I'm just going to draw that as best I can on my picture here. So I think it looks something like this. And again, sorry I can't draw super good on here, but something like that. You get the idea. Just sketch what you see off the calculator. All right, that's it. So that's kind of the whole process with all the asymptotes and using a calculator from there. Thanks for watching.